Okay, so this is the third part of the turn in place animation setup. So I think at the second part we have completed the set root yaws offset logics, and now what remaining is we have to process this root yaw offset accordingly and play the animation plus rotate the root bone of the mannequin. Right? So if I show you the current progress, it's still printing 0 as the root yaw offset because it's not currently being processed. Okay, so let's start processing that root yaw offset value. So I can start with idle uh, and at the idle state, at the output animation pause, let's create one update binding called update idle state play. We have it, then let's call it as update idle state, and I think we can move this to the stateford functions category. Yeah, and there let's check. Yeah, let's first get the convert to animation state, and let's check is state is blending in. No, is state is blending out with this animation state, and if it is blending out, you can do something, and if it is not blending out, you can mark, you can set root yaw offset mode dash accumulate, and we can start processing it. So in order to process it, I will create a new function called process turn yaw curve, and make sure to mark it as thread safe, and I'll call this function at here and move it to the turn in place category. And if this one is blending out, which is if it is true, we can get the property access node and we can check its orient rotation movement. And actually this stuff will be useful when we are testing the forward facing stuff, but I'll add this stuff right now, then we won't miss these sort of checks, right? So if the rotation movement is applied, then we set the turn yaw curve value. We have one called turn yaw curve value, no, right? So we need a one variable to store the turn yaw curve value, right? This should be float. Assign it to, yeah. So the forward facing turn yaw curve value is false, is 0 if the rotation mode is false. Okay, now then let's implement this process turn yaw curve value function. So let's so let's get this turn yaw curve value, and I'll promote your local variable called previous turn yaw curve value. Then then what? Then let's get the curve value from this turn yaw weight, and if it is nearly equal, I don't need this much of a tolerance. Let's add 0.0001% of a tolerance, and if this is true, we can do something, which is we can set the turn your curve value as 0 and the previous turn your value as 0. If it is not true, which means false, then we can set the turn your curve value, but we need to divide this value with another value, which is a curve value called remaining turn your curve. So if I show you what it does, basically we have this turn animations, and we have these two curves called turn your weight and remaining turn your. So we have to now use this value and divide it using actually divide the turn your weight by using this remaining turn your value and get the return plot value. So I'll get the curve value called remaining turn your and promote it to a variable called curve remaining turn your. Compile. So the default value is this one, and we can divide it by using the value of this curve, right, and set it to here, turn your curve value. Okay, then I will comment this entire thing called turn your curve value calculation based on curves, and once it is done at here, can check the previous turn curve value. If it is not equal to 0, which means we can set or update the root to offset value, right? So I think we have a function called set root to offset. If this is true, let's get the previous root to offset minus turn your offset curve name and previous turn your curve. Subtract there, right? So these are values taken from curves, and we reduce that curve values from the existing root to offset value and update it accordingly, right? Okay, so I'll comment this thing as reduce root your offset by the amount of rotation from turn animation, right? So this amount of rotation of turn animation will be actually taken from the curve values, right, which has been already assigned at here. Okay, So that's how we can process it, and it has been attached to here, right? Now maybe we can make a play test. Now you can see at the idle we have a what do you call, we have a turn, right? So if I try to move it left, we have turn left. If we have try to move it right, we have turn right. Okay, right. So that's the first step, and it's almost done, but I think we can introduce set of updates to our other state node functions as well, right? This is the first one. So at the animation graph, locomotion, yeah, let's go to the start state. Let me quickly look at my documentation. Yep. So let's add set of state node functions to here. So they won't become relevant. I'll add a new state node function called setup start state. Push it to the state node functions, and here we can do yep. I think some of these turn your values will becomes in handy when we are choosing the forward facing stuff. Yeah, but let's get the property access first. Property access, not this one actually. Property access, get movement component, rotation movement component, and if this one is true, which means we are at the forward facing mode. If it is false, there is nothing to be calculated. So here I'll create a new variable called max turn new value, right? So let's assign it to here, and the turn your curve value is 0, right? And we have to determine what is our last direction, right? So how to determine our last direction? Yep. Do we have one acceleration change event? Yeah, we have it. So here actually we can determine our last direction. So we have function called select cardinal direction from angle. And as the angle, we can use this one, the dead zone. We can use cardinal direction dead zone. As this one, we can use local velocity direction. And here we can use local velocity 2D. And if the vector is 0, If it is not 0, then we can use the current direction, right? And this will be the last direction. Let's push it to the world velocity. Right. And then then we can update this thing at the setup start date state anim layer as well. So setup start anim layer. Yeah, this one. So here let's get the if you forgot where this function is, basically it is at the anim graph locomotion start. This one I don't become relevant. So let's get the last direction, and again property access to rotation to movement, and let's set the last direction first, and let's make a selection here based on this value. So if this one is false, we can get the last direction. If it is true, we can get the forward. Okay, now we can go back to this setup start state anim layer, right? And there let's get that last direction, and if it is forward or yeah, if it is true, or for now I'll take this as true, but later on we can add multiple different logics. But maybe I'll remove this for now. So we have to determine our start state. Yeah. Yeah. So let's add a new variable called reached end of turn boolean. This is a character state data, and let's see if it is forward. I'll mark it as reached the end of turn. But I think much more complex logics can be applied to here when it comes to the forward facing stuff. So I'll mark it as to do add start anim based logics, right? So now if I search for to do, I can later on go there and implement it, right? And I won't miss the implementation. So I'll mark it as to do. So now we calculate it, which is fine, and then can make an update binding as well. name this as update start state, and let's move it to the state node functions. Right, and there let's get the context is state blending out, and let's convert to the animation state, assign it to here, and if this is false then we are at the transition. So let's get the property access pin, get movement component, bring rotation to movement, and here if this one is false then we can mark root to offset as hold. Right, otherwise we can process the turn yaw for forward facing. Right, so we have a one function called process turn yaw curve for the calculating the root to offset based on the curve values, but when it comes to the forward facing animations we have to explicitly process the turn yaw again. Therefore I'll create a new function called process turn yaw forward facing, and I'll implement it later, but first let's assign it to here, and then we can get that reached end of turn variable, and we can select the root to offset mode based on that. Right, so if we reach the end of turn we can blend it out, if not it should be accumulated over time. Right, yeah, so mark this, make this process turn yaw curve forward facing as thread safe function, otherwise it will give a compile error. Okay, then let's implement this function real quick. Yeah, so this is somewhat similar for the process turn yaw curve. Therefore I can copy some of it actually. So I will copy the entire thing first and paste it here. And let's promote this to the local variable. So we have the reference here, compile, save. So these logics will remain same. This one is also same. This one is same. But then once this is become 0, we have to get the max turn value and check whether it is 0 or not. If it is 0 then we do nothing. If it is false we can mark it as reached the end of turn. Okay, and then what? And before jumping to this condition we have to make a further check here. So let's get the absolute value from turn yaw curve value and the max turn value. So if the magnitudes are greater than the other one, which means there is a possible turn, right? So if it is greater, we can set the max turn value as the turn your curve value, like this, and I'll add reroute node. If not, we keep as it is. And then we can do this checking at here, and then we process the root to offset. But when it is processing, I think this logic should be a bit more improved. We need this one, but first we should get the local velocity direction angle with offset. So how to get that? Yeah, so let's go back to the update velocity data function. Update velocity data. So print thread save functions. Yeah, at here. Before recording the local velocity direction, soon after we calculate the local velocity direction angle, let's get it here and subtract it from the root to offset. Then we have the local velocity direction angle with offset. So I'll promote this to a variable called local velocity direction angle with offset, and assign it to the world velocity category. Okay, and let's go back to our process turn your forward facing function, and now we have the reference for the local velocity direction angle with offset, and let's self divide it with the from the turn your curve value and multiply it with this value, right? And let's take the absolute value here and multiply it -1, and then actually we can clamp this value within a certain range. So clamp the float, minimum value should be this one, maximum value should be the other one, right? So we multiplied it with -1 because then we can get the minimum value, right? And then let's assign it to here. Basically what we have been done was we get the curve values, we get the offset, self divided, and we clamp the values and we reassign the root to offset here, right? Okay, so that's the processing turn your forward face function, and it will be applied at here at the update start state. Okay, so the start state is also done. Now the remaining part is stop state, right? So let's go there and let me quickly look at my documentation. Yeah, again let's create a new function, state node function called on update, called update stop state. and I'll move it to the state node functions. Right, this one is pretty much simple. So this is the, since this is a stop animation, we have to mark it as accumulate. So let's say if the state is blending out, and let's convert it to the animation state, and if this is false, then simply we mark the root your offset mode as accumulate. All right, those are the stuff that we have to done for the forward facing turn in place animation process parts. So now test it out. So at the strafing mode, turn in place works properly, and let's switch it to the forward facing mode. And at the forward facing, yeah, you can see that rotation is sort of working, but it's almost not noticeable because the start, stop, or cycle animation will be played at first, but you can see the root TO is actually processing. Okay, great. Now let's switch back to the strafing mode, and we have to rotate the root bond alongside this root TO offset, right? Otherwise, still it seems like, you see, foot sliding is there. The animation is playing properly, but the character mannequin is still sliding over the ground. But this is not the expectation. We have to rotate it, play the animation simultaneously, right? Not in different times. So in order to do that, we have to rotate the root bone alongside the root offset update. So let's go to the anim graph, and here here I'll promote this to a, not here actually, this I will save it as locomotion catch pause, locomotion catch pause. So actually this is like a reference for the locomotion graph. So instead of attaching the wires again and again, we can organize it a bit further, right? So let's get the default catch, no, use catch pause locomotion catch pause, and then let's rotate the root bone, right? Rotate the root bone. You don't need to rotate using pitch. We are considering the yaw. So let's get the root offset, and let's select it because we have added this variable called disable root offset. So in case if we need to disable it, we can use this variable. So if it is disabled, then root offset is 0. If it is not disabled, we are attaching the dynamic root offset here, right? Then it will rotate the root bone accordingly, right? So the root bone, in the sense, actually I can show what is the root bone means. So if you go to the skeleton, this is the root bone, right? So you have to rotate it something like this. See, instead of foot sliding, So whenever we rotating, now we are rotating the root bone alongside the mannequin, and it will be a bit more realistic at the turn in place states. So now I'll save this cache pose as turn in place cache pose, and I'll use it here. Compile, save all. Let's play test it. Okay, now you can see we are not foot sliding. Instead of that, we have a proper turn in place animation because we are rotating the root bone accordingly. See, the no foot sliding is involved. Okay, great. Yeah, so let's play test the forward facing as well. Yeah, forward facing also it works, but it's almost unnoticeable. But for the strafing mode, it's pretty much neat. Okay, now I can remove that debug print string at the event graph. Okay, right. Okay, so I think this concludes the turn in place animations. It's pretty much long setup because it has set of complex logics that we have to apply iteratively. But finally we have a proper turn in place animation setup. So thank you, and I'll see you in the next episode.